Hello, welcome to a new video. Today we're going to try to solve this problem called construct binary tree from preorder and Inorder traversal. I say try because just by looking at this problem, like, I don't know, it doesn't make sense to me, but I'll just go through the process of trying to make it make sense, I guess. And then I'll probably watch a video afterwards, but I'm going to try my best to solve it by trying to make sense of it. So yeah, the statement's pretty simple, but the implementation and the thought process of how to solve it is kind of confusing. So given two integer arrays, preorder and inorder, where preorder is a preorder traversal of a binary tree and inorder is, yeah, the same thing. Construct and return the binary tree. All right, so, well, we kind of know what preorder is. We access the current node, then go left and then right, and then so on, right? And so preorder here in this case is 3. So we access the current, 9, and then 20. So left, right. So current, left, right. And then we say 15 and 7. Because current, left, right, right. And then inorder is accessing left. No, it's accessing left. Then going all the way left, then accessing current, then going through all right. So in here, just by looking at it, it will be 9, 3, and then it'll be 20. No, it'll be 9, 3, 15, 27, right? So yeah, it's kind of interesting how it is. But I guess one thing that we should note, I guess I'll just use LeetCode to kind of take notes. So one thing to note is that we can see that preorder holds first node in binary search tree, non-binary tree. But that's one good thing to note. And then, yeah, that kind of makes sense. So, so preorder holds the first node in the binary tree. And then we can say that wait, also I gotta take notes. So preorder is cur left, right, and then inorder is left, cur right. Right, so just take notes of those, I guess. Yeah, and then preorder holds the first node in the binary tree. And then inorder holds I think I gotta solve this with like a full binary tree, I guess. So it's like 3, just like 9, 20, 15, 7. I guess we can have like 10, 11. So it points like this. Right? So inorder will basically be this. Order will be this. I'm trying to think of like an algorithm, because I know we're gonna have to use the array because we're given two input arrays. I should have noted that too, but that's fine. So inorder will be all the way left, then current. So 9, then right. Yeah, and then it'll be 3, 15, 27. Yeah, I'm correct. And pre-order, it will be current left, right. So 3 left, 9, 10. Current left and then right. So then 9 will be 11 and right 20, then 15 and then 7. Is that correct? Yeah, that makes sense. Yeah, that makes sense. Okay, so wait, what is pre-order? 3, 9. Okay. Okay. Just want to double check. So pre-order holds first. No, pre-order is cur left, right. So 9, 9, 10, 11. Okay. So, how are we going to construct this? It's a very good question. So we obviously know that pre-order is going to be the first. So we know that we're going to use pre-order. Okay, anyways. We know that pre-order is going to be the first thing we're going to write into the list. So the 3. I mean, right into the tree. So we get the 3, make that into a node. Right? Now what? We have to get the left and right. Okay, so the dog keeps wanting me to just like chill with her, but I'm studying. She's like scratching the like stuff like she can reach to like let me know that she wants to chill. I can't. I'm studying. I'm studying. Right. So we know we need to get the left. Right. So, Okay. So, Okay, this is gonna be tricky. So we know we want to get the left. I want to construct the left first. Mostly because we see 9, 10, 11 here. 9, 10, 11, or 10, 11, 10, 9, 11 here. How do we do that? Oh. How do I do that? Well, I'm sitting in a weird position right now. Wait, I'm thinking. We know that pre-order is going to be the root. So So why not just make... But how will I know if it's left or right? Oh, I see. I see. Because this 3 is right here. This 3 is in the middle. Hmm. Okay, so if I know that to the left of the 3 is all this, then we can construct all this. But I don't understand. Okay, so if that's the case, then like okay, so we got the 3. The 3 is right here. So left is equal to this whole thing. Right's equal to this whole thing. Let's focus on the left. So if we know this 3 is right here, we want to get the left, then we have to say that we give all this. We have to do something with the left. So left, right? And then we're like, okay, so we know that 9 starts here. How do we solve this? I mean, well, we can do pre-order, right? We'll definitely do pre-order for like the 9. But how do we get the 10 and the 11? Well, we can't just say that the 10 and 11 is 9 is the index minus 1 and plus 1. Because if we look here, when we do this 3, right? Okay, we get this 3. We don't just say that the next index is minus 1 and plus 1, right? We don't say that. We just say that 3 is, we just put 3. Okay. Then I guess one question we can ask is like, are the no.vals unique? Okay, they are unique. Okay, so we can say something like, why do I even have this? So we can say like, we can possibly, so dot index. We can use dot index to get the index of, preorder of cur dot of preorder cur to find it in in order. So that's a good thing to note. So I guess we can say that we get this, then find its value in order. And then we know that the left is definitely here. We know the left is definitely there, right? So if we know that the left is definitely there, then we can just say, do this. Definitely get this for the left. And what will preorder say? So we got this 9. Then we want to go to this 9's left. It has a left, right? So if it has a left, it will go to its left, which is just here. Just 10, right? We see the 10 here. We input that 10 from the preorder. Okay. Then we go to 10's left. There's nothing there. We have to go right. So we go back up to the 9. Then do the right. So so what was that algorithm that I just did? What's that algorithm that I just did? I gotta write it down. So plan. So what was the algorithm I just did? So n is equal to the index equal to no. So we start from the roots. We say that tree node. So we say that tree node is equal to node is equal to tree node of preorder at 0. Because what I'm basically doing here is I'm crossing off each one, right? So, okay, so cross this out, preorder 0, then find it, and find it in, so n is equal to, the I is equal to, 3, I is equal to preorder 0 dot index And then, okay, so I get the index. I see it's right here. Then, oh my god, wait, my mind is like breaking. Oh my god. I gotta stop. Okay. So, okay. So I was at the point where we get the index of it, right? And so, where was I? Yeah, and then to go to the left, we have to say, oof, we have to say that. Oh, what do we have to say? What do we have to say? We have to say. Okay, so we found the node, get the index of it. Then we know to the left of it. So we can say that, we have to say something like build preorder from, no, build preorder from something. But we know that Inorder is with Inorder from all the way to I? Because I'm pretty sure is slicing in Python inclusive or exclusive? I'm pretty sure it's inclusive. Oh, the endpoint's exclusive. Okay, so that's fine. So we know that the left is equal to this, right? But we still got to figure out preorder. For preorder, I would just say like, for the left side, we know that the preorder is just these, right? So I guess we can say that maybe we have to do like, to get the length. So maybe we gotta set it up. So maybe set up for recursion, I guess. So so preorder can be like length of left is equal to in order, I guess. In order of I would say that preorder is from 0 to length of left. But I'm pretty sure it's, oh, you have to say 1 to length of left, which is 3. So it'll be 1 0 1 2 3. But the endpoint is exclusive, so we gotta say +1, right? That's how. So that's how we get the left. Yeah, so that's how we get the left. And then so if we just continue on with this algorithm from the left. All right, so first off, right? So we say the first node is tree node preorder at 0. Okay, so preorder 0 is right here. Okay. Then I'll just make this a new tab. Okay, then we say that I is equal to the index of preorder dot in of no. Oh no. What does dot index do? So dot index. No, index of, so in order, index of 3. Index of pre-order 0. Dot index Python, what does that do? Okay, cool. So I is equal to in order dot index of preorder 0. Okay. Okay, and then okay, so we get the index, which is right here. It's at index 3. Okay. Then set up for recursion. So for in order, so length of left is equal to from its left all the way up to the index of 3, which is 3. So 0, 1, 2. So in order that we're going to send for recursion is 10, 9, 11, which is all this. And then pre-order is just going to be that we're going to send is 1, which is inclusive, because 1 is right here. So 9 to length of left plus 1, length of left is 3. Yeah. It's 3. So we do plus 1 because it's exclusive. This is index 3. But since the since the end length of slicing is exclusive, we add the plus 1 so we include it. Right? So plus 1. And so what we're dealing with here is just this. So this is the left. So this is what we're dealing with right here. Then we do it all over again. Okay. We do it all over again. So node is 3. Can I say like no dot left? Equal to this. Then we could just return. Okay. We gotta say like if not node, if null, return null, right? Okay, so return node, I guess. Okay, so here, let's do the whole algorithm again. So node is equal to tree node preorder. So we get this 9. So this is 9. Okay. And then what happens is that we get that 9 in preorder and in order. We get that index, which is 1. Then we set up for recursion. So length of left is equal to in order all the way up to I inclusive. Exclusive. So we get this 10. So length of left is just basically so left is basically this. This. And then preorder is one all the way up to length of left plus 1. So that's 2. Wait, what? Length of left is 1. Okay. So 1 plus length of left, which is 1. Oh, so okay. So it's just going to be this. Okay. So this is set up for recursion. Okay. And then what we do is say that that left is whatever this pops out, and this is going to pop out just 10. Right? So that makes sense. So yeah, I think that's cool. I think that's honestly cool. So we kind of set up for the left. Yeah, I think that's kind of cool. And now we need to make no dot right. So if we go back to no dot right, I'm gonna start from the beginning. So no dot right is basically Will this algorithm work though? We'll see. But let's go to the right. So the right is just to the right of 3. So of in order. So I think length of right is equal to in order starting from I plus 1 to everything else. And then, okay. But then how do we get to here? That's a real question. We say, what do we say? So we can say that we're gonna give preorder the length of okay, so preorder to the length of we want to exclude all this. So this is index 3 from length of left is all the way here, just 3. So it's just 0, 1, 2, 3. Length of left plus 1 all the way up to that. And then it's just in order I plus 1, so in order I plus 1, so yes. Huh. Is this, did I solve it? Did I actually solve it? Because preorder length of left, which is 3. Preorder length of left, which is just 3, is right here. Plus 1, so we start right here. On the right. Then in order is just all this. I did solve it. Let's just go through it again. I'm kind of unsure. So, okay, so let's go back where we started. Let's go back to this algorithm. So at this point in the algorithm, we got the 3. Okay, so at this point in the algorithm, I mean, let's just restart the whole algorithm. Why not? All right, so we get preorder in order. We say that node is equal to tree node, preorder is 0, so this we get this 3. Then I is index of in order is in order in dot index of preorder, and its value 3, which is right here. So I is equal to index 3. Cool. And so now we need to set up for a recursion. So length of left is equal to in order all the way up to I exclusive. So in order for the left is just right here. And then length of right is basically in order I plus 1. I plus 1 all the way up to the whole thing. So I plus 1 is right here. So 15, 20, and 7. Okay, cool. So now we have in order right there. Preorder over here. Now we gotta do preorder for the left. The preorder left is basically 1. So we're gonna skip this 3. We're gonna remove the 3. Oh, I should just do it here. So what we're gonna do is we're going to remove the 3 initially, and then length of left plus 1. So the length of left plus 1, so it's I. Oops. But yeah. Yeah, I mean, I could just say like I, like length left is equal to I, but I can just do this just to make sure. I don't know. Like I'm just like this just makes sense to me. So length at in order at I. So length of left is basically 3. Yeah, so plus 1. So 4. 0, 1, 2, 3, 4. It's exclusive, so we're gonna delete this. And oh wait, 1 is, yeah, 1 is right here and it's inclusive, so that's our for our left. And then yeah. Do I even need length of right? I don't think I do. I'm pretty sure that I can just say I plus 1. I'm pretty sure I can say I just I plus 1. It's so confusing. Like it's just so confusing if you don't have notes down. And then from there, we do this, and then we say node is equal to preorder 0, 9. Cool. So that's our left. And then we do this whole thing again. Where preorder is basically no, we get I, so I is now 1. Cuz this is we get the index of where 9 is in order, and then that index is 1. And then yeah, and then we say to the left node we had to go to build again. So preorder is going to be from 1. No, wait, preorder is going to be from 1, which is this 10, all the way up to exclusively I plus 1. No, yeah, I plus 1. So that is 1 plus 1. So 2. So it is for left, so one all the way up to 1 plus 1. So 2. So boom. Okay. And then now in order is basically all the way up to I. All the way up to I. All the way up to I? But it's x. Oh, wait, no. Okay. Yeah, I is 1. So this is 0, 1. Okay. Boom. And now we have 10. And then we just say, no, that left is equal to 10. Okay. So that's cool. Then we do this whole thing. We already did that. I is equal to whatever. I is equal to 0. Right. And then left is equal to yeah. So then preorder is just going to be 1, 1 and 1. So that's basically nothing. Yeah, it's gonna be nothing. So okay, then in order is just going to be all the way up to 0. Exclusive. So can slicing in Python return an empty list? Okay, so that's fine. The length of preorder is equal to 0. Then just return none. But then this will say none. None. And I think that's fine. Then this whole thing could be done for the right side, which I just did. I'm pretty sure. So what I'm going to do is I'm just going to just copy this. Copy this and just code it. So, okay, so base case. So if length of preorder is equal to 0, then return none. Then if that's not the case, then we have to get the node. So node is equal to tree node. Tree node preorder first val. And then I, so index of node in order. In order is equal to in order dot index of pre. Let's say I. Because we don't want to do dot val because it's not a node. Okay, cool. So I is equal to in order. So the index I is equal to the index of the value of preorder in order. So then we can say that node dot left go to build tree, and we're going to give it the left side, the preorder, left side of preorder. So preorder 1 inclusive is once we exclude the node that we just made the node for, or the value that we just made the node for, and plus 1 all the way up to and then in order all the way up to I, and then node dot right is equal to build tree preorder I plus 1 all the way up to whatever, because yeah, I plus 1. All this. It also represents length. And then I plus 1. Yeah, yeah. And then in order. It's confusing to explain, but it just makes sense when you have all the notes and like in your head. I just can't really explain it because there's so much that I can represent, right? So, and then in order I is basically I plus 1. Yeah, because yes, I plus 1, right? And then just return node. Then we have to call. That's pretty much it. I just run this and it works. Oops. Oh, I have to say self. Yes. Oh my god. Wait. Oh my god. I'm the go. Holy shit. I did it. 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 How long did it take? An hour. Oh, that's fine. My brain hurts. I did it though. It took an hour, but holy freak. Okay, so for its for runtime complexity, I mean for space complexity, I'm pretty sure it's O of n. Because we're storing. I don't know, because we're storing every. Yeah, we're just using a list. In general, we're storing every element more than once again. I don't know. I can't think. And then for time complexity, it's O of n log n or whatever, because we're doing basically like half each time. So yeah, pretty cool. My brain hurts. I'm done.